Hi everyone, my name is Annika Visser and I'm from a company called Unspun. We're an American tech startup and today I'm going to talk a little bit more about what we're doing to unlock localized and on-demand production in today's fashion industry. Okay, cool. So in 2022, stores in the US were sitting on a record amount of unsold merchandise worth a staggering amount of $732 billion. Supply chain disruptions due to global and complex supply chains threaten profitability. Textiles globally remain an economically important sector, but it has a major impact on the environment, as you are all very well aware. And then even luxury struggle to move their goods. Unsold inventory for LVMH last year was $3.2 billion worth, and that's just one company. And not only that, but we are also plagued by, with the e-commerce boom, plagued by returns due to poor fitting garments. All of these issues are both financial and ecological liabilities. The key drivers for change that we believe is pushing the need for on-demand and localized manufacturing are complex and fragile supply chains. As I just mentioned, we're plagued by long and manual supply chains. Unless you are Shein or Temu, seems like everyone is talking about them these days because of the way that they are super efficient, but not everybody can afford, or not everybody has the technology to operate in the efficiencies that they do. We're simply producing too many garments, and as the previous presenter also pointed out, at least 30% of that is often unsold, and only 1% is recycled. So before we dive in, I want to mention that I know that we don't have all of the solutions. We by no means have a silver bullet fix-all that's going to just make all the problems of the fashion industry disappear. And there are many complex issues that need to be solved. So we also know that there are raw material innovations that are happening. There are process innovations, AI and digital planning, which I guess is a lot of the work that you all are doing, energy efficiencies, legislation, and we believe even the end consumers have a role to play here. Material innovations, I want to speak about that for a moment. Even if it's going to, at a product level, you can work to drive down the emissions or the impact of a single product. If we are to economically grow, you're producing something that's 10,000 pieces, the environmental impact of that product is going to be increased because the net emissions of the amount of garments that you produce is going to increase. So in terms of the process, we haven't been really innovative in the actual process that we have been manufacturing garments. Yes, we've improved efficiency, but if you think about it specifically for wovens, which is what I'm going to focus on today, we still make a roll of material, lay it out, cut the fabric from there, and then sew the garments into 3D pieces that are then shipped around the world. So, for example, the sewing machine, yes, it has been made much faster and it's more efficient, but essentially, since it was invented, we haven't really rethought this model. So we're basically taking all of these issues and thinking, what if we could create garments on demand and close to home in a localized supply chain? What would it take? So it would obviously take innovation, but innovation is often blocked by a lack of infrastructure, high adoption or production costs, and the high cost of labor, as well as technical skills that are lacking, specifically for on-demand and localized supply chain if you want to produce near-shore or onshore. So these three issues are interlinked, and they not only block innovation, but they also block the localized supply chains. So can we mitigate these issues by combining our production into smaller, more local manufacturing hubs? To mitigate the cost, can we combine multiple production steps? And for skilled labor and the labor cost issue, can we automate parts of the process? So how will we do it? This is the company that I work for, Unspun. Our proposal is to produce on demand using 3D weaving. The technology that we are developing, called 3D weaving, calls for industry-wide adoption of on-demand, intentional, localized, and zero-waste manufacturing practices. We are building the solutions needed to propel the industry into a new era of production and consumption. So how does 3D weaving work? How is it different from 3D knitting or 3D printing? So 3D knitting is obviously, knitwear is a category in of itself. I'm not going to explain that to you all. But with 3D printing, I guess the problem is that, yes, you can create organic shapes with 3D printing, but the substrates that are used are not what we want to be wearing on our bodies, right? We're used to wearing yarns. We want something soft and comfortable. So how do we kind of emulate what's happening with 3D printing, but do that with actual yarns, because you can't print yarns, at least not yet. So we've come up with the concept, Yarn to You, which is essentially you're going from yarns into a weaving machine, and then a semi-finished product comes out at the other side. My video is not going to work, but not to worry. You can watch it on YouTube if you Google Unspun. But I did some slides just in case that happened. So essentially, I just want to explain to you how 3D weaving works. You'd wonder, oh, why don't you have any photos of an actual machine here? It's because we are heavily IP protected, and our lawyers will not be happy if I show how the machine actually looks. But looks simple. It's obviously very more complex than that. But we basically have 2 creel walls filled with the warp yarns. These are around 2,500 warp lines that are suspended around a core. That's the circular image over there. And then this core basically moves upwards, and the weft is inserted horizontally and continually. And as the weft is inserted, obviously the warp lines, it's a jacquard loom. Everyone is individually controlled, and we can also control the diameter of it. So that creates the 3D shape. The output is then essentially a seamless tube that can be of any shape, size, kind of weave structure that you design it to be. And then there are some finishing steps that happen, and voila, you have a pant. The cool thing is that the actual weaving steps to make one pant, it's about 10 minutes on the machine, and then 10 minutes of finishing steps. So it's much faster, much more efficient, which is definitely something we need to do if we want to start talking about on-demand or local production. So another thing, and this is where we also save a lot on cost and the cost and emissions because of transport, is you all know the regular traditional supply chain is complex. And I do want to mention that, no, I'm not going to mention this now, later. So we're essentially proposing that by 3D weaving, you're going from yarn into semi-finished product. You can ship that directly to your consumer. So skipping a bunch of the traditional supply chain steps. Now, obviously, I spoke about lack of infrastructure earlier on. How will this be implemented in reality? So our concept is the idea of microfactories. So building more micro hubs for manufacturing. We've already built our first microfactory in Oakland in California. Here we are developing these machines, and we're also producing for our first brand partners. And the idea is that once we've calibrated these machines for the brand partners, they will then license the technology, and we will implement these machines into their existing supply chains. So it's like we partner with both manufacturers and brands to license the technology. In practice, this is what a microfactory could look like. So you have 10 minutes of weaving on the machine, and then whatever the design of your product is after, you can automate adding your back pockets, belt loops, waistband, etc. So it can be really quick, it can be really efficient. I've already touched on the benefits a little bit. So these benefits are not necessarily only for 3D weaving, but on-demand production in general. So obviously you save a lot of time because the transportation or warehousing downtime between the production steps is non-existent. Well, 1 second. We're also unlocking a faster process because of nearshoring, and then you can have quick replenishment and production, so you don't need to keep anything, keep any finished goods inventory. And then one of the key benefits from weaving over 3D knitting, which I guess 3D knitting you can also deploy in microfactories, but it's just one category. We also have a lot of wovens that are still being sold in the world today. So it's much faster than 3D knitting, where 3D knitting takes essentially one yarn, and that one yarn goes back and forth. I'm sure you're familiar with or if not, there's a whole garment machine by Shimaseki, which is a wonderful technology, but the technology is very slow. If it's slower, then it's also more energy intensive. So, yeah. Then optimal. So even if you are as efficient in your planning as Shein or Zara, in your production, you might still need to air freight goods, which I think Stanley yesterday, he was talking about how if you air freight goods, yes, it makes the world much smaller, but you can get hit with a lot of duties and tariffs, import taxes, etc., and also the emissions from flying around. Another one, sorry, I'm not matching with my slides right now, but another benefit is that you are reducing cutting waste. Because we're going from yarn into semi-finished product, the cutting waste is reduced between 1% to 4%, depending on the design of the product. And I know that the percentages of cut waste is all over the show, but I've heard the industry standard I'm taking for now is around 14%, but I know it can be more and it can be less. But this is one thing that we reduce the waste of. And then the last one here is about minimizing your returns with made to measure. And I'm going to talk about how we can, with on-demand manufacturing, also unlock a made to measure business model that will then also solve not only for the unsold inventory problem, but the returns that you see from e-commerce. And then it's also a very clean way of producing. Obviously, you're having a small footprint. All of the steps can happen underneath one roof. 3D weaving enables on-demand production. I've already spoken about that. And then minimizing unsold inventory. And very exciting, we also have the capabilities to start thinking about true hyper-circularity, which I will explain in a bit. So, what can we make using 3D weaving? Basically, any product that you can envision as a tube. So because the machine is creating 3D woven seamless circular tubes, if you think about like a pant leg, obviously we've started with pants because that's where our fit software is we have the most expertise. But if you start thinking about jackets or even dresses, accessories, hats, bags, even footwear, we're starting to think about some footwear applications. And then actually the technical capabilities of the machine, I've mentioned that You can do any pattern because this is a jacquard-enabled loom. You can create variable diameter, so this is how you'll create custom sizes, different shapes, different products. Yarn properties and weave properties, and material type. So we're material agnostic, so like fiber agnostic. We can use cellulose, we can use recycled polyester, we can even use wool. The major constraint right now is on the strength of the yarns, because the yarns are under extreme pressure due to the way that the machine is set up. So we need to use yarns that are above 10 newtons. But other than that, we're good. We can weave with anything. And that's only for the warp. It's really interesting because for the weft, warp is this way and the weft is this way. So the weft is inserted circularly. And for that, we have some shuttles moving around the core of the machine. And we've used so many different, sorry, that's the laser again. We've used a lot of different weft materials that we've experimented with. So basically here you can see a couple of products that we made. One of those, the one on the left, is using cotton in the warp. It's a twill weave, and then we're using some lurex thread for the first two in the weft. And both of those have the same warp. So you can really create a lot of differentiation by just switching out the weft yarns. And the cool thing is that generally in weaving, you have to load the warp beam, where with us, because every single creel is individual, you can actually just switch it out really quickly. So it's much easier to create different textures and use different colors, different yarns, etc. Then the one in the middle, that's a 100% cotton one. It's a really beautiful pants. And then the one second to last on the right, this is a really interesting pant we made for a collaboration with Lata. We actually had some dead stock like tapes laying around our factory, and we just were like, oh, let's try these on the machine, and the effect was really beautiful. And we actually created garments that are now being sold to consumers using this waste tape. This was a very exciting moment for us last year at New York Fashion Week. We did a collaboration with Lata. Once again, all of these garments have the cotton in the warp, and we've just played around with the materials used in the weft, and you can create a myriad of different shapes. The one on the left, actually, we use some twine from Ace Hardware. So no, this is a little bit more experimental. It's a little bit more boutique. This was a collaboration with a luxury brand, but we are also working on the more mass market retail. So a couple of weeks ago, we announced this. I'm finally allowed to say it in public, which is great. But yeah, we have a project with Walmart that we are basically going to try and replicate, we're going to do it. We're going to replicate one of their best-selling chinos using 3D weaving, because obviously one of the unlocks with sustainability is that we don't want the customer to necessarily know about it. The customer is just going to buy a great product. So we kind of want to, on the sly, replace that and also help them produce in the US, which is, as a American company, they have a big incentive to do so. So yeah, that's exciting, in the works. The other side of the coin. So now we've been talking about on-demand production, but we have not touched on, on-demand production for zero finished goods inventory, but there's also another side to the coin, returns. Returns for online sales, especially now that e-commerce has boomed much faster during COVID than initially expected. This graph is from the European Environment Agency. They recently did a study that showed that a fifth of all garments bought online are returned, and 70% of that is due to the fact that it doesn't fit well. What happens to these garments, because it takes a lot, the reverse logistics is often cost as much as it cost them to produce the garment, so it's then destroyed. So it's estimated between 22% to 43% of all of those returned garments are destroyed. These are garments that they are brand new resources. They've never been used. In the study, they did take recycling to mean destroying as well, because you're taking something new and you're downgrading it. So how do we solve that? Custom fit, automated custom fit patterning. So Unspun, our company, we actually started while we were developing this 3D weaving hardware technology, because to innovate hardware, don't know if you know, but it takes a really long time. So in the meantime, while we're working towards this future vision of a customized digital supply chain of the future, we started testing the software that would then power these 3D weaving machines. And we actually launched a custom fit denim brand that you can still buy the jeans online, and I'm wearing them. But basically how this works is somebody would take a 3D body scan using an iPhone. Now they can also use Android. We don't own the scanning technology, so we would partner with other scanning solutions, but our software would extract the measurements from the avatar that we get, and then it would go into our system. We have an API with Browseware, which would then allow us so those patterns that you see there, they were automatically created by our software for one person. So it's kind of enabling this tailoring model to be scaled, because it's all happening really, really quickly, and the algorithm is using all of these data points to create custom fit patterns. We'll then do a quick fit check with heat maps using Browseware. This is also automated because we can connect, software APIs, wonderful things. And then we basically send this 2D pattern to our partner facility, and then they would cut and sew the jeans as normal. They are not 3D woven yet, but now that we're starting to work on the 3D weaving technology, the idea is to marry all of these technologies together so that you can have automated, localized, on-demand, and if you want, also custom fit products, so that your customers, that you can reduce your return rates due to ill fit. Another technology that we've been working on is a fit platform, fit recommendation. We obviously know that not everybody's ready. Well, most people aren't ready to make the jump towards custom. It's still very, very niche. We hope to grow that side of the business, but for now, we have the capacity to either produce in sizes and extended sizes, or we can produce custom. For extended sizes, what we can do to help, and this is a technology we also sell as a standalone. All of these technologies do not need to be related to a 3D weaving machine. But how this would work is a customer would either fill out a fit survey or do a body scan on your website, and then an avatar would get generated, and they can virtually try on their bodies the different sizes, and we would then recommend the best fit for them. And obviously the evolution of that would be custom fit, but for now just fit visualization to help mitigate your returns. I'm going to skip the slide. Oh no, it messed up my heading. So the full vision for Unspun is that eventually we want to plug all these technologies together so that you can go from scan, either in-store or mobile, then you design your garments, the data gets sent to the closest microfactory, and then these garments are then woven either custom or in regular sizes, and then shipped to the customer closest to them. How much time do I have? I need to speed up. Okay, so quickly I want to talk about the impacts of on-demand production, because obviously I can say on-demand is so much better, but we recently did an LCA, which I guess everybody knows, is a life cycle assessment that looks at all of the stages of the product's life cycle and where the most impacts are. For this life cycle, for this assessment, just want to call out that we did not include the customer component for the study. So what did we find? We basically found that producing on demand. So let me first tell you what we measured. So we conducted this life cycle assessment using 100% cotton pants. So everything is exactly the same. The only difference is that one is made in bulk using air-jet weaving, and the other one is made using 3D weaving technology. So there are two things that obviously improved our emissions, energy consumption, and water consumption. One is the fact that the 3D weaving machine is so much more efficient and you are skipping so much of this general supply chain steps. And the second is that by producing on demand, you obviously have 100% sell-through, which we took that 30% unsold inventory as a standard baseline. Now, this is something that doesn't usually happen in LCAs. Usually people look at LCAs like a product by product, but we think it's very important due to the prevalence of the unsold inventory issue that brands and retailers mostly start looking at the impact of those unsold goods as well. So you need to look at it holistically, both in your costing models as well as in the impact that your products have. Otherwise, it's not going to make sense. So, hence why we did this. The numbers speak for themselves. And then naturally, different sell-through rates will have different levels of impact. This is a emissions breakdown by process for the cotton pants, which is more detailed. I'm going to just skip over it. We also studied the impacts of 3D weaving if it was without the different sell-through rates, just to show the impact of 3D weaving. It's in itself compared to air-jet weaving. The numbers are obviously a little bit lower, but still significant. Especially the electricity requirement is much lower. The water didn't make a huge impact because we were comparing mechanical processes that both didn't use a lot of water. So on demand is obviously the winner here. And then we can't stop there. We need to keep innovating, and we've already started thinking about how can we even further improve this technology. And the answer is circularity. I guess circularity is a hot topic, but how do we actually make circularity work? Everyone is talking about it. There's a lot of upcoming legislation that's incentivizing brands and companies to invest in circular supply chains, circular business models. Vega, our 3D weaving machine, the products are circular by design. So remember, I was speaking about how these products are seamless and the weft is continuously inserted. So because you don't have seams, the idea is that when the customer would bring them back, that we can unweave these garments, roll them back onto yarn spools, spools, and put them back into the machine if they're in good enough condition. So you don't have to do any mechanical recycling. So this is a technology that we are working on that will work with these 3D weaving machines. Another concept that we've been playing around with is this concept of hyper-circularity, where we could actually take fully fashioned knits and unwind them and put them into the 3D weaving machine. So for fully fashioned knits, any dead stock inventory. Okay. The last thing I want to chat about is just localization. So as a part of this study, we also studied the impact of that localization can have on the distribution of clothing. We basically studied one supply chain where the product went 100 miles by truck to the customer, and the other one where the product went 7,000 miles away, not by air freight, actually by sea freight and then road freight. And these were the per product impacts. Obviously, this is very nuanced data because it depends on what you're shipping, is the container full, etc. But just because that's interesting. And then some other innovations. I only left 1 minute to talk about. So there are other companies Variant 3D and by Bore, they are doing something similar to what we're doing, but with knitwear. So they are actually connecting two existing microfactories that have 3D knitting technologies, and they basically would provide you with the front end design, so you can do the designs using their software, and then they will connect to the microfactory hub for this on-demand 3D knitted products. Then there is Platform E. Platform E does a lot of things. First one is that they have this made-to-order management system that allows you to connect to your factory and send, manage your orders. And then they also have a custom visualization platform whereby they create digital twins of your products, so you can plug that into your POS or website, and customers can actually real-time design the products that they're going to make. And then Genealogia, they share a similar vision with us of producing on demand in microfactories. Their specialty is around denim and denim washing. So they also have this concept of urban factories and zero water washing facilities. And then Resonance is an actual microfactory platform. Yeah, this is just how people would work with us. And that's it. Our founding mission is to help the fashion industry drive 1% global carbon emissions reduction through automated and on-demand localized manufacturing. Okay, well, thank you so much, everybody. Thanks for listening.